Hi, I'm Bob Whiten. I'm the product manager for HILCO, and I'll be your instructor for this series. If you're having difficulty removing a screw and you're looking at it and the screw doesn't appear damaged in any way, but you still have trouble backing it out, it could be that there's some Loctite or some super glue freezing that screw into place, or even some corrosion. The first thing that we recommend to do is try to heat the screw, and the best way to do that is with a hot fingers machine, because we can really concentrate the heat on the screw. It can also be done with a frame warmer or a salt pan, but it's not recommended with plastic frames because you really have to heat the screw a lot, and on plastic frames it could warp or damage the frame, so it really is only an application for metal frames. But with the hot fingers we can really concentrate the heat. And the hot fingers basically is an electric pair of pliers. I have a foot pedal on the ground, and when I depress that, whatever I'm grabbing with these pliers heats up. So what I'm going to actually do is burn out any glue or tight bond that is holding that screw into place. And we do that by grabbing the screw top and bottom. You want to be careful really just to grab just the screw. You don't want to be grabbing any other piece of metal, or you could discolor the frame slightly. So I get the screw with the hot fingers and I depress my foot pedal. You can see probably a little smoke coming up over there, and that's burning out any of the glue or Loctite that is in there. Okay. You want to be careful not to get any of that smoke in your eyes or inhale it, because it's not a pleasant experience. The next thing we're going to do is just use a standard optical screwdriver. I'm going to use the ergo driver to remove it, especially when I'm having problem because a screw is frozen in place. I like to take the ergo driver and put it into a pistol grip formation so I can really get a lot of torque. We'll talk about blades just for a second. You want to use the proper blade for the job at hand. The screw head that I'm using here, or trying to remove, is about 2.0 millimeters, about a 2 millimeter head. And I'm going to use a screwdriver blade that corresponds with that head size. I'm not going to be using something that's oversized, because it could damage the screw even further and give me more trouble in trying to back it out. So I'm going to use the closest blade size I have, and there's probably 6 different sizes in the industry that are available. It's good to have a few of each kind on hand. And I'm actually placing the frame on an anvil to brace it. You could use the edge of a table. You could use a bench block. You really don't want to hold that frame in one hand and the screwdriver in the other and try to back it out or even put in a screw, because if the screwdriver blade slips, every technician knows what happens. It gets jammed into your finger, and that also is not a pleasant experience. So what I'm going to do is I'm going to use the edge of this anvil, and I'm going to get my screwdriver blade in there. And I did burn out all the glue, and we're able to remove it. And this application will work in either the hinge or the closing barrel area. If you're trying to remove a screw, you have to remove a screw, but it's been damaged and you can't get a screwdriver blade into the slot of the screw. There's a tool, a screw head slotting file, or some people call it a ribbon file, where you can actually cut a new slot in the screw and then back it out with a standard screwdriver. On this particular frame, we have a head of the screw which is really gnarled and chewed up. There's no way you're going to get a standard screwdriver blade in there. So I'm going to take the ribbon file and I'm going to cut a new slot into it so that I can back it out. Place the frame, steady it on the anvil or a bench block. Very carefully in the center of the screw, just start filing lightly, let the file do the work. Being careful not to touch any other part of the frame. You don't want to scratch any finish. Okay. Now we have somewhat of a slot in there. It's going to be good enough for us to get the screw out. Place our blade in there, and now we can back it out. Okay. We're able to remove the screw by cutting a new slot in the head. If you're having a little trouble getting the screw out. You can take a pair of cutters. I find that's a great tool to grab a damaged screw and pull it out the rest of the way. On the opposite side of the frame, I have a slightly different scenario where the head of the screw was completely sheared off. So what we need to do is to find another method to get it out, but sometimes the screw will protrude out the bottom of the hardware a couple of threads, 2 or 3 threads, enough where we can actually cut a very tiny slot in the bottom of the screw. So here I'm going to attempt, we get the screw coming out about 2 threads, and as close to the center of the screw I can get to. But once again, very carefully try to cut a slot in the center. Take a standard screwdriver blade. Yeah, I think we've got it. I can just take my cutting pliers and just remove it the rest of the way. I've got a large piece of the shank coming out. And we can just back the screw out the rest of the way. We've not damaged the hardware in any manner. Able to remove it without drilling. The next method of screw removal, we're going to use screw extractors. And basically in the optical industry, there are 3 different sizes of screw extractors for different applications. Depends on whether you're going to grip the screw from the top or the head and extract it out, or sometimes you can actually attack the screw from the bottom and turn clockwise and push it out. In the first application I've set up here is we have a frame that has a damaged screw head, and it's almost completely flush with the hardware, so I'm not going to use the ribbon file on this. I don't want to risk damaging the frame, and I'm going to try removing it with a screw extractor. Because the head is about 2.5 millimeters in diameter, I'm going to use the largest size of the screw extractors, and they fit inside a standard optical screwdriver. These blades fit in any handle, and I'm going to brace the hardware on the anvil and then take my screw extractor. Now, the screw extractor has barbs on it, 4 barbs that will grip the head of the screw, and it will grip enough, hopefully, where I can back it out. You can see it's turning the screw. Sometimes they can be a little stubborn. Here we go. And by using the large extractor on the head of the screw, we're able to remove it. Now, if the head of the screw is completely sheared off, our only option is to go on the bottom. And the screw isn't protruding out of the hardware, so I can't use a ribbon file or a screw head slotting file. So I'm going to try an extractor. And I would move to excuse me, the smallest size. Okay, put that in the screwdriver. And now what I'm going to do, instead of trying to extract it out or back it out, I am going to turn clockwise and try to push it out. There it goes. That one was quite easy, because there's really only a couple of threads that are holding that on. A couple of turns and it'll push it out. If your practice happens to have a power tool, such as a 5-speed variable Dremel or a drill press, you can actually take these screw extractors and insert them into the Dremel or the drill press to enable you to get much more torque than your hand would ever be able to provide to extract the screw. Insert it into whatever chuck the tool has. Now we have the screw extractor in the tool. When you turn on the machine, it's moving at a much faster rate than your hand obviously would be able to turn at, and it provides much more torque, and you can zip the screw out much more easily.